Hello everyone, today we're going to present about our projects. So the topics of our project is the effects of class imbalance to performance of binary classifications, and our advisor is Ajahn Vacharapan Suwan Santisuk. And for the member, we have Anjisa Desha Likhitgun, Jeepath Lodlat, and Pawalat Jay.Joy. So let's get started. With the first one. For the first topic that we're gonna talk about is project objectives. So there are three objectives in our projects. The first one is collect publicly available datasets for trainings and testing the classifier. The next one is we want to implement various classification methods in MATLAB programs. And the last one, quantify an effects of class imbalance on classifications in accuracy, specificity, and sensitivity of various classification methods. For the scope of the projects, the classification method under considerations are support vector machines or SVMs, random forest, Bayes classifier, and neural network. We also review other classification methods such as deep belief networks and dynamic multi-hyperplane partitionings as guidelines for further this research in the future. And for the datasets for trainings and testing are the datasets that publicly available from open sources. Our methodology in the projects. We divide the methodology into three parts following our project's objectives. For the first project objective, which is collect publicly available datasets for training and testing the classifier. So first, we research about the primary effects of class imbalance, and then we discover the website that collect the reliable information dataset. So the website that we choose is UCI Machine Learning Repository websites. So here is our website, which is UCI Machine Learning Repository website. So if we see that there's provide so many data that we can choose the newest datasets and also the most popular datasets. And if I click here to show all the dataset, we see that they collect all the data into type that it will be easy for the user to find the dataset, and they also provide so many details of the datasets on the website as well. And here, if I try to download the Y dataset here, so I can click it here, and then it will show the data folder that we can download it, and they also show the datasets information that will provide all the details and information in each column and row in the dataset. So if I click here and then we download the y.data, and then we got the datasets from the UCI machine learning website. So here is a table of characteristics of 10 datasets, includes features, sample, class ratio, and their applications that we collect from UCI machine learning websites. So after we discover the website in order to collect the reliable information dataset, then we choose 10 datasets for testing and training the classification method. Then we coding the MATLAB program to convert the files from .data to .mat. Then we can use this dataset for the MATLAB program, and then we label datasets from multi-classification to binary classification. So here is a MATLAB file that we use to convert the dataset in .data to .mat. So for example, for the Y dataset that we collect from UCI website, now we try to convert from Y.data to Y.mat, and here now we already convert it and we got Y.mat. In here we can check all the data by click on it, and it will show all the data that we can use for the classification after that. Now we try to label the file from the multi-classification to binary classification. So first we load the dataset y.mat. Now we separate the y dataset into y target and y length, but we can look at the dataset. So we see that the first column will be in the class of the datasets or the type of Y. So in this data, there are three types or three class of the data. So now we use the class of the data to the target file, and the rest of them will be the length file. So we got the condition that if the y target equal to 1, it will be -1, and if more than 1, it will be 1. So for the length file, it will be the list of the data. And now for the result, it will show in the total of the feature and the number of sample or the cast plus 1 and minus 1, and it's also show in the cast ratio as well. So here is the result, and we can solve the result as well if we click on the data file into the wide length. So here is the wide length, and for the cast is already labeled into -1 and 1.
For the methodology, we will show about the classifier process in each classification method, which consists of the SVM, Bayes, neural network, and random forest. So we can divide the process in 3 steps. The first one is set up the classification method for text and tone by using the different function of the MATLAB program. In this file, we need to set up the classification. In each classification, we need to use the function of the MATLAB program. Let's start with the SVM or support vector machine. We use the fixed SVM, and the second one is Bayes. We use fixed CNV. The third one is the neural network. We use fixed net. And the last one is the random forest, which is a very complex because we need to calling the auto file, which consists of the auxiliary file, the CART file, the CART/MX file, and also use the stochastic board and evaluate stochastic board file too. The next step is set up the variable to calculate the performance, which consists of the accuracy, sensitivity, and specificity. In this file to set up the variable to compute the performance of classification, as you can see in the MATLAB program, TP of 2 positive be the 0, FN of 4 negative be the 0, TN of 2 negative be the 0, and the last one, FP of 4 positive be the 0. And in this part is to show the formula to calculate the performance of classification. The accuracy equals to TP plus TN divided by the n sample. The sensitivity is the TP divided by the TP plus FN. And the last one is the specificity equal to the TN divided by FP plus TN. The last step is compute the performance. So in the file, we need to show the result of performance of classification. In the figure, you will see a lot of the dataset that commented. So this line is show about we calling the function predict label, and we also calling the performance evaluate function. The next step that you need to do is insert the name of classification that you want to know the performance. Or for me, I insert SVM classification, and after that you need to select the data that you want to classification. And I also select the PLRX dataset and then run the program. So the program, after the program running, is the result of performance. The accuracy of PLRX equal to 0.7143. The sensitivity equal to 1, the specificity equal to 0. And if I want to change the classification, I just delete the SVM and I insert the next classification that I want to know, maybe random forest, and then run. And this is the performance of PRLX by using the random forest classification. The accuracy equal to 0.6758, the sensitivity equal to 0.9077. The last one, specificity, is equal to 0.0962. From the histogram, it shows about the performance of SVM classification. The x-axis is represent the ratio of the datasets, and the y-axis is represent the 10 datasets. So you will see the different color of the bar. The yellow one is the specificity, the orange one is the sensitivity, and the red one is accuracy. For the average accuracy of SVM classification equal to 79.513%, the average of sensitivity equal to 77.611%, and the average of specificity equal to 70.676%. The next histogram is performance of Bayes classification. For Bayes classification, the average accuracy equal to 75.362%, the average of sensitivity equal to 75.371%, and the average of specificity equal to 66.88%. The next histogram is show the performance of neural network classification. The average accuracy of neural network classification equal to 55.08%. the average of sensitivity equal to 0% and the average of specificity equal to 98.581%. The last one is histogram to show the performance of random forest classification. The average accuracy of random forest classification equal to 83.036%. The average of sensitivity equal to 80.427% and the average of specificity equal to 77.039%.
The next one is linear regression. Linear regression is a basic and commonly used type of predictive analysis, and it is used for finding linear relationship between target and one or more predictors. The simplest form of regression equation with one dependent and one independent variable is defined by this formula. By each array will collect the performance of classification and the ratio of dataset to be used in the linear regression by using function polyfit. From the function in theory that I had shown you previously, we have put it in MATLAB, where B0 is constant, B1 is the regression coefficient, X is independent variable. So, in our project, linear regression has been used to check the performance of each classification method or p-value. We set the x-axis to be ratio of the dataset, and we have set the y-axis to be the performance of classification method under the condition of alpha equal to 0.05, and then we have set two situations of linear regression. The first one is H1, is represented in case of the performance of classification method related with class of ratio. The second one is H0, is represented in case of performance of classification method unrelated with class of ratio, which means if the value alpha is greater than p-value, it's going to accept H1. Otherwise, if the alpha value less than p-value, it's going to accept H0. For example, I'm going to check the linear regression of accuracy of SVM, the performance of accuracy classifier SVM. And here is the linear regression of accuracy of SVM. Remember, X is represent ratio of dataset and Y is represent performance of classification method. And we got the p-value is equal to 0.597. And we go back to check is except H0 or H1. It said that if alpha is greater than p-value, it means accept H1. If it's not, it's less than, it's going to accept H0. We got the value that p is equal 0.597, which means it's greater than alpha. So, which means it's going to accept H0. And here is our result. Summary of performance of classification method. We got the highest p-value at accuracy of neural network, and we got the lowest of p-value sensitivity of SVM. Furthermore, you can see the interesting output in neural network is NAND. It is not easy to use the zero value substitute in hypothesis testing formula to compute the linear regression because that is the reason for occurring NAND insensitivity rule, which means it's nothing in mathematical. The next one is H value. As you can see, our result p value is all greater than alpha value, but does not only mean it's accepted H equals to 0, but also represent the performance of method are not depend on class of ratio. However, the ratio has the probability to affect the performance of classification, as you can see on the graph of linear regression on the dataset point. Spread out slope, but actually is not large enough, and we have no Y-length ratio of the dataset to consider the linear regression. We have come to the end of our presentation. In summary, we spoke about how to download dataset from UCI website, send dataset for tracing and training, convert file from .data to .mat, label file from multi-classification to binary classification, classifier process in each classification method, histogram, demonstrate performance each classification, and linear regression. And here is our project result. All the results were based on the input variable in classifier program and performance evaluate program. The first one is conclusion of SVM performance classification. We got the average of accuracy is 29.513%. The average of sensitivity is 77.611%. And the last one is the average of specificity is 20.676%. The next one is the conclusion of Bayes performance classification. Average of accuracy is 75.362%, and the average of sensitivity is 75.317%, and the last one is the average of specificity is 66.880%. The next one is the conclusion of neural network performance classification. For the average of accuracy is 55.068%, and the average of sensitivity we got 0%, and the average of specificity we got 98.581%. And the last one is the conclusion of random forest performance classification. We got the average of accuracy is 83.036%. And the next one is the average of sensitivity, we got 80.427%. And the last one is the average of specificity, it's 27.039%. In conclusion of linear regression, we using t-test for consider the relation between class ratio of data is effect to the performance of classification or not. The result of the linear regression show that the classification of datasets are not effect to the performance of classification because of the ratio is not wide enough to consider to be in effect. And it is end of our presentation. Thank you for your time and please stay safe.